Right, now that we are pretty comfortable dealing with systems of equations with two variables and two equations, we're going to make the systems a little bit bigger. Now I know when I'm dealing with linear systems like on this previous pages, these are straight lines in the plane. Okay, this is the line y equals 5, 6x minus 2, for example, so it's a line that goes this way. When we're working with three-dimensional linear equations, and it's still considered linear when everything is to the first power, okay, then instead of each of these being straight lines, those three equations represent planes. A plane is like a sheet of paper that goes forever in every direction. Now, that's not something that I am able to draw well on the board, and your author has some good sketches in the book that if we have three planes, how they can intersect. I just Googled it, looking for a picture that I was going to kind of copy and paste and put into my presentation here so I could point at it. And I found it's kind of a hokey little 7-minute video, but I didn't watch the whole thing. But I am going to put a link to it. I'm going to embed it in our Canvas shell because I think for some of you it'd be worth your time to watch it. It would make sense. You could visualize better what's going on. I will say if you're a math ed major, and I know we have a few of those this semester, it would be a great idea to watch that video and see how to visualize what those solution sets may or may not be. Now the good news is when the systems get bigger like this, we don't have to learn any new methods, new approaches to the systems. We're still going to use substitution, or we're going to use elimination. And elimination is what I'm going to use because because more students use it. Okay, but substitution works too if you're careful. So the first thing I'm going to do is I'm going to look over my system, and I'm going to pick a letter to eliminate. Since all three of these coefficients are different, I'd rather not deal with the x's unless I have to. Okay. One thing I notice when I slide over to the y's, or if I look at the z's, okay, I have a 1 or a -1 there. So that'll be my shortest path. Also, since these two, the top and the bottom equation already are opposites, my vote at my desk is going to be that I want to eliminate the y's. Okay. You can still solve this system eliminating x's. You can solve it eliminating the z's, but I'm going to work with the y's. The other thing to keep in mind is we're not, even though we have three equations here, we're not ever going to work with all three equations at the same time. So when we do our elimination steps, we're only looking at two of the equations. Again, because the top equation and the bottom equation are already set up so that the y's will go away if we add them together, I'm just going to rewrite them down here. I'm going to add them together, and I'm going to get an equation that only has x's and z's. Okay. Once I've chosen my letter and I've decided to eliminate that letter, then I'm going to come back and now I have to take into account the equation I haven't messed with yet. It doesn't matter whether I put it with the top equation or whether I put it with the bottom equation. Of course, I'm only going to put it with one or the other. But because of my 1 and -1, I'm going to have the same number of steps. I'm just going to go with the top one. Still eliminating the y's. Okay, if I eliminate the z's using the top two, then I'm no farther along than I was when I started and wrote the problem down out of the book. So if I have a 5y here in the middle, I need this coefficient on the top to be a -5y, which means I need to multiply both sides of that top equation times a +5. That gives me positive 20x minus 5y plus 15z equals -10. Remember, when we multiply every term of both sides, not just the one that we're trying to change. Okay, we've broken the rules if we've done that, so I multiply every piece of both sides of the equation by whatever I need to. Now when I add the two equations together, I get 23x plus 14z equals 5. So what I have now, I have two equations. This one has x's and z's. This one has x's and z's. Okay. What we'll do now is the same thing that we did in the last set of videos. Okay. If I have two equations and two letters, I know how to deal with that. Okay. Maybe I'll write them separately over here so we can look at them and see them more clearly. So once again, I'm going to do substitution or elimination. My vote is is elimination, what I'm going to do instead of what I'm going to say. And I'm going to get rid of the z's. So all I have to do is change the top equation here. That gives me negative 4x minus 14z equals negative 24 on the top equation. The bottom one didn't change because it already was the way I needed it to be. So 19x, my z's are gone, equals negative 19. And when I solve for x, I get x equals negative 1. Now once I know that x equals negative 1, I know I have to start going backwards and figuring out what the y's and the z's are that go along with it. Okay. Now some students try to go all the way back up here and plug in the negative 1 into these equations. If I do that, I still have two letters in each of those equations. So we're going to do what we call back substitution, meaning I'm just going to go back to the step that I just came from. Okay. I could point up here to my black equations there. Go back up here. I'm going to pick one of them, top or bottom, maybe the top, and I'll plug in negative 1 for x, and that should give me enough information to solve for z. Only after I have both x and z, then I'm ready to go back to the top equation, top set of equations. It doesn't have to be the top one literally, but any of these. I'm just going to go to the top because it's right there. So negative 4 minus y plus 3 times 2 equals negative 2. When we solve this for y, don't forget that when you subtract 2 from negative 2, you get negative 4, not a 0 there. So y is equal to positive 4. Once I know x and y and z, instead of writing an ordered pair, okay, now I have 3 letters, and we're still going to write them as an ordered triple, meaning the x-coordinate comes first, and the y-coordinate comes second, and the z-coordinate comes third. Okay, these 3 planes in space intersect, and they intersect at one point, this point right here. So we're not looking